Artifacts. Artifacts are complementary elements that improve the diagram understanding. They only illustrate, they don't execute nothing, okay? They don't affect the process. Therefore, the motor is not going to consider them when we launch a process. All they're going to do is help us add some additional information to a diagram. So here we've got vertical bands, horizontal bands, roles, adapters, titles, nodes, okay? So we can create all kinds of bands, vertical, horizontal. We can color them in. We can insert different icons for business rules, for adapters. That would just, we have a graphical representation on the diagram of a certain point in which a connection is taking place. Okay, but it's not necessary. All of this is optional. And then here we can add nodes, text, and whatever else we want to identify or better identify what's happening in the process. Okay, here there's some other lines, errors. So with this, we can also point at certain objects and maybe add a note or whatever. Um, Obviously, bands can be useful in simple processes like the one we're seeing right now. But sometimes by using them in complex processes with many objects and different performers, not only do they make the diagram much more difficult to understand, but they're also much more difficult to maintain. So if bands are not used, the performer and the action can be performed wherever we want. It can be displayed however we want. Okay, we don't have to display them. We're not restricted by these bands. Most objects must have a name or a description that clearly identifies the part of the scenario that's going to be covered. So here we can see the exact same process at the left and at the right. Here at the left, we can see we've used bands. So here it says client, support, and development. And yes, we could say it's easier to follow. But at the same time, we have to take into account how we can follow the thread of the flow through this process. For example, here, I know the flow goes this way, then it goes down here. Apparently, it could also go this way. It could also go this other way. And it could also go this other way and connect to this task over here. Okay, so as we can see, it's a little bit difficult to follow. It's not that easy. And here we can see the same diagram. Here we haven't used vertical or horizontal bands. And it's actually much easier to understand because we've got first the start event that triggers the process. Here we have support that performs some calculations, and then all these different things could happen. Okay, so we've got outlets 1 to 5. Okay, and since we didn't have to classify them in these vertical bands, it's much easier for me to position them however I want, and that way whoever sees this process can understand it much easier. Okay, so in most cases, especially when we're talking about complex processes with lots of pages, lots of different performers and so on, it's going to be much easier to not use vertical and horizontal bands. Obviously, if we're just working with very simple processes, these vertical and horizontal bands could help us. The last thing I'd like to mention is that when we save the diagram, the modeler is actually going to tell us what's wrong. So let's say, for example, in this first scenario, we've added a gateway. And in this gateway, we have several outlets. And these outlets don't have a name. Okay, so the system is going to tell us, look, in DX1, it's this gateway here, the outlets need a name. So it's going to tell us what we've done wrong. Okay, so as it says here, when saving the diagram, the modeler is going to check the syntax. If it's not correct, it's going to give us instructions on how to solve this. Okay, but then there's other scenarios where the logic is wrong. It's not the syntax, it's the logic of whoever diagrammed this. So let's say we put a DA up here and we activate several different objects, and here we have a DX. Okay, here we know the process is going to get stuck, or it's probably going to get stuck, because if the flow reaches this DX, once it reaches this DX, the DA is only going to receive flow from this thread or from this thread, but never from both. Okay? Well, in some occasions it could receive it from both, because if the flow goes this way and it goes out, it goes this way and it goes straight out, that would be okay. But what happens when the flow goes this way and the DX sends the flow this way here? Okay, in this case, the CA would never receive this inlet that we can see up here. Okay, so in this case, the syntax is correct, but the logic in the process is not correct. Okay, so obviously we can see here it's giving us a tip. When we've diagrammed this, it's giving a tip and it's telling us, look, the DX gateway needs, the outlets need a name. Okay, so it can tell us to fix this, but what it can tell us is to diagram with logic. Okay, because the system can't know if that's actually what we want or not. Okay, so when we're talking about syntax, the system is going to be able to detect it for us and indicate what we have to do in order to fix it. When it comes down to logic, it's going to be the consultant or whoever is diagramming to apply the logic that is required for each one of these diagrams. Thank you for your attention.